the force exerted by the tugs on a vessel and what will be the resultant direction of travel if more than two tugs are involved. So here we have a tug 1 which is pulling a barge at an angle of 040 degrees true with a force of 1000 newtons, which is the unit of force. There is another tug 2, which is pulling the same barge at an angle of 355 degrees true with a force of 6000 newtons. Additionally, a third tug 3, is pushing the barge from south with a force of 500 newtons. You have to find the overall force to the nearest newton on the barge and the direction of the travel to the nearest degree. Alright, so let's get started with the question here and draw the diagram. So you have a barge here that you can draw. Alright, let's call it B. So you have a barge here and this barge is being pulled in two directions. So there is one here. You can draw a perpendicular to denote the north-south line. This is where the third tug is pushing from. So let's say this is the north, this is the south. The third tug is pushing from the south, of course. So the first tug 1, let's call it 1. Tug 1 is pulling the barge. I don't know what's going on with my pen here. So it's pulling the barge in a direction of 040 degrees. This is 040 degrees true. Alright. It's pulling the barge at 040 degrees true at 1000 newtons of force. The second barge is pulling it in a direction of 355 degrees true. 355 degrees true. But 355 degrees will be measured clockwise from the northern hemisphere, right? So ideally, if you think about it, 355 would be this angle here. So if I need only this angle, this is actually only 5 degrees. I don't need that 355 for this question here. So I will get rid of this 355, but you get an idea, right? So we've got 5 degrees of angle here on the northwest side and 040 degrees true on the northeast side. So this is tug 2 and this tug is pulling the barge at 6000 newtons. So there are two tugs. Alright, and third tug is pushing at 500 newtons. This is tug number 3. Alright, so you have to find the overall force and the direction of travel. So let's first start with the overall force. Now, when these two tugs are pulling, they are pulling towards the north. Alright, so you can say this is the direction of pulling. The third tug that is pushing is also pushing the vessel in the same direction. Alright, so we can say that the movement of the tug along the y-axis is all in the same direction. Alright, this direction there. So if I need to calculate the force along the y-axis, let's see what I have to do. So let's take these two tugs, tug 1 and tug 2, as two separate triangles. Alright, so let's say this is triangle 1. This is triangle 1. So the tug 1 is pulling at 1000 newtons at 040 degrees. So if I want to find the overall force along the y-axis, it would be this axis here. Let's call this A. Alright, this A. So if I have to find out A, what do? I write cos of 40 degrees equals A, which is also the adjacent, divided by the hypotenuse, the longest side, 1000. Or A equals cos of 40 degrees multiplied by 1000. Alright. So similarly, if I have to find the force exerted by tug 2, it will be very similar. So this is 5 degrees. We have seen in the diagram already 6000 newtons of force being pulled. And if I need to find the force along here, which I can call B, I can say that cos of 5 degrees equals B upon 6000, adjacent upon hypotenuse. Or I can say that B equals the force along the y-axis due to tug 2 equals cos of 5 degrees multiplied by 6000 newtons. The force along the y-axis caused by the third tug is clearly 500 newtons. It is just pushing it from the south and pushing it towards the north. So exactly it's moving towards the north along the y-axis. So I can say the force exerted along the y-axis is equal to A plus B. So cos of 40 degrees multiplied by 1000 plus cos of 5 degrees multiplied by 6000, and the third tug pushing it 500 newtons. Remember, if the tug was pushing from the north towards the south, if it was pushing in the opposite direction, you would subtract that force here. But because all three tugs are pulling and pushing the barge along the same north south axis, along the north, it's pulling, it's in the same direction, and the third tug that is pushing is also in the same direction, all these forces are being added. So if I have to add them up together, I will say cos of 40 degrees multiplied by 1000 is equal to 766.04 plus cos of 5 degrees multiplied by 6000 is 5977.17 plus 500. So if I just add them up together, I get 7243.21. So I get 7243.21 newtons along the y-axis. Alright, now let's find the force along the x-axis. So it's the same thing again, except that this time this is tug 1, this is 40 degrees, this is 1000 newtons. You have to find the force along this axis here, x-axis. Alright, similarly for tug 2, so this time I call this A, and tug 2 is 5 degrees, 6000 newtons, right? And you have to find the force along this axis here, and I will call this B. Alright. So in this case, let's say tug 1 case, we have sine of 40 degrees will be opposite upon hypotenuse, A upon 1000. So A equals 1000 times sine of 40 degrees. And over here it will be sine of 5 degrees will be equal to opposite upon hypotenuse, B upon 6000, or B equals sine 5 degrees multiplied by 6000. Now in this case you have to remember the two tugs are pulling not on the same x-axis. One tug is pulling in the northeast direction, the other is pulling in the northwest direction. So the movement is not along the same direction of x-axis. Alright, so the movement will be along somewhere here. So we don't know which way. It depends on the tug which is pulling harder with more force. So the movements are in opposing directions. So that's why you cannot just add these two forces together. You would have to subtract one from the other. So you have to subtract the smaller from the larger. So I don't know what is larger and what is smaller unless I add them up. So I'll just go A minus B here and hope that one is larger than this other, because the force cannot be negative. So if in case A is smaller than B, then we will just make it a positive number. Alright, so here we have 1000 times sine 40 minus 6000 times sine 5. So sine of 40 degrees multiplied by 1000 newtons gives us 642.78, and sine of 5 degrees multiplied by 6000 gives us 522.93. So this case it has worked out well. The larger number has been written before. So if I subtract one from the other, you get 119.84. 119.84 newtons is the force along the x-axis. So we have the force along the y-axis now and the force along the x-axis. This is the force along the y-axis and this is the force along the x-axis. If you want, you can round them off, but you can leave it the way it is. So we know now that this is the y-axis force and this is the x-axis. So this force along the y-axis is 7243.21 and along the x-axis is 119.84. Now the overall force is the resultant of the two forces here. We call it R. Alright, we call it R. So how can we calculate the resultant force? Well, think of it like this here. So if I draw a line parallel to the y-axis force, alright, if I draw a line parallel to the y-axis force, this will also be equal to 7243.21. So now this becomes like a right angle triangle, right? So this becomes like a right angle triangle where this is R, this is 119.84 and this is 7243.21. So the longest side, the square of the longest side as per the rules of hypotenuse equals the sum of the squares of the other two sides. So 7243.21 square plus 119.84 square. So if you square the number and you add them up, so you have 7243.21 square, you will get 52464091.1 plus 119.84 square, you will get 14361.63, and you can just add them up together, 52464091.1. So you will get R square equals 52478452.73. Square root of this number 52478452.73. So just square root the number and you will get resultant force as 7244.20 newtons. That's a resultant force. All right, that's one of the answers. The other answer that you have to find, this is the overall force. So our resultant is also the overall force experienced. Now the other part is the direction of travel. So which will be the direction of travel? This will be the direction of travel, theta. So when the two tugs are pulling, when the tug is being pulled along the y-axis and the x-axis, the resultant direction of travel will be that angle, because we always measure angles of direction of travel from the north-south axis and we measure it clockwise like this, right? This is the direction. This is always the course or the direction of travel. So in this case as well, this will be angle theta. So how can I measure angle theta? So in this case, draw a parallel here. All right, draw a parallel here, and this parallel will be equal to 119.84, same as x-axis. And now treat it like a right angle triangle again. So we will have a right angle triangle. This is the right angle triangle, 119.84 and 7243.21, and you have to find out this direction of travel here, right? So this will be nothing but tan of theta equals opposite upon adjacent. So 119.84 divided by 7243.21. So you will get tan theta equals 0.01654, or shift tan. So theta equals tan inverse of 0.01654, which is equal to theta equals 0 degrees 56 point about 9 minutes. So I can just round it off to 1 degree here. So that means the direction of travel is north 1 degrees east or 001 degrees true. Alright, if that makes sense. Because of course you can see the force along the y-axis is much larger than the force along the x-axis. So that's why there is not much direction of travel away from the north-south axis. It's just a little bit only. Alright, so Guys, I hope this video is useful. Please watch it a few times. Remember to calculate the force along the y and x axis after careful consideration of how the tugs are pulling or pushing along the y and x axis. So if they are pushing or pulling along the same axis, the forces will be added. If they are doing it in opposite directions, add the force along the same direction and then subtract the forces in the opposite direction. Alright, thank you for watching today's video, and bye for now.